Hello and welcome to Montville Math and uh repping the hometown Montville, Connecticut. It be how it be. A nice place, forests and all, nice little town. All right, so what we're gonna cover today is basics of vectors and Euclidean space. So like obviously 1D is a line, 2D is a XY plane, 3D is like a XYZ like system that is like a 3D manifold where you can like where 3D space exists is like reality. So looking into that, right, we're starting off with vectors. Okay, so vectors are just mhm, uh, you could call this vector alpha. All right, so they'll start from the origin. All right, and they extend somewhere into 2D space. Boring. Um, and now, okay, let me try to be more comfortable here. And or try to know what I'm doing. Uh, mm-hmm. Vector addition and multiplication. All right, so probably should explain what a vector is. Okay, so vector in basic terms, which sometimes are the best terms. Uh, Arrow. It is just like it can either be represented as a ray from the origin with some angle and some magnitude. All right, so this is still alpha. Magnitude is represented by one bar on each side, or as like the x coordinate of alpha and y coordinate of alpha. All right, now that's cleared. All right, so because bullying yourself is fun, I'll try to show a 3D vector, then get into what this textbook's saying. All right. Mm-hmm. Yeah, assume it cuts to the origin. Yeah, nearly got it. There you go. I'll redo that part because it should cut to the origin as is. Okay, so finished, finished. So this is the x-axis, this is the y-axis, this is the z-axis. Um, Minecraft for some reason uses the z-axis as the y-axis. I don't know. Or actually, it doesn't matter. They like, as long as you make sense of the thing. Like for example, this dot, the kind of dot this one is. So this could be like x is equal to 2, y is equal to 1, z is equal to 1, and y is equal to 2. So this represents 2, 2, 1. Alright, so there's your 3D version. I'm not going to draw much more in 3D because I'm not ready to, complicate things given my already potato abilities regarding the crafts of drawing. There's schools for that, and or if you're good enough. All right, should be the y-axis. All right, so ignore that. What's the first thing? Adding vectors. Right. So, easy to, like, if you have the vector numerical note form, the coordinate Cartesian form, like x1, x2, x3. Oh yeah, like y and z are like completely arbitrary, right? Like you can make them up. I could refer to them as x1, x2, x3, where they all represent different variables. This really means x, y, z, but like that looks dumb, so I'm not gonna write it on this. But so if you're adding x1, x2, x3 by y1, y2, y3. Now a lot of teachers teach like this. Just remember this is like x, y, and z is equivalent to x, y, and z in like in the how do you call it, regular form. It's just like how to notate a different vector. So the 1 is x, 2 is y, 3 is z in like the regular form. But in algebra you could interchange variables, do whatever. So this is equal to x1 plus y1, x2 plus y2, x3 plus y3. I'm using dots because I'm lazy, but you know what I'm trying to say. Okay, now that's trivial. Like if y is like minus, then you could just put a minus here and it'll work. All right. Boring. What's next? Believe me, it'll get less boring, and there'll actually be some actual difficulty. It just sadly we have to get through this garbage. All right, not garbage. That's being mean. All right, so All right, there you go. Optimal like Mewtwo King. All right, so um, if I'm doing plus like alpha, like y1, y2, y3. All right, then you just multiply them as is. Like multiplying just goes through. So like assume I ignore this. That'll be equal to alpha y1 dot 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 dot. I'll put dot dot dots to indicate like y2 and y3 because they're implied. Because once you have y1, y2 and y3 are intuitive. All right, so what's next? All right, multiply 0. Like if alpha is 0, right? It turns into 0. Multiplied by 1, it's the same. Like these are a lot of like abelian factors, so generally like they're important in vector spaces, like the identity rule and like the 0 rule, which so if you multiply 0 by something it turns into like 0, and the identity can change. For example, like in multiplication you multiply by 1, in addition you add by 0, and what the identity does is like whatever you start off with you keep it. That's what it means. Bruh. Okay, now that we finished that, like this is literally just waffling. All right, PEMDAS. I'm not gonna. It's basically vector PEMDAS at this point. Ah yes, adding vectors on the thing. So if you have a vector going here, a vector going here, all right, vector alpha, vector beta, crappy beta. All right, give me 1 segundo. Un segundo, por favor. Yeah, there you go. Alpha, beta. You're adding them. What do? There's a tip to tail method. So you just All right. I'll delete the x and the y. They're kind of given. You just at the tip of alpha you add beta, and then you get alpha plus beta. All right. And the reason why this works is because you know how like if you add b plus a, it's the same as adding a plus b. Well, show that add alpha to the tip. This should be the same spot. Oh, and that final vector, right? From the origin to this again. Yeah. This is alpha, plus beta. Yeah, so like if I do this, you'll end up with the same vector, which is just over here, and you pull it to the origin. There you go. Okay. For example, if you had 1 minus 1 plus 1 1, which is, similar to what's here. It'll end up with 2 0, which is similar to what's here. Just, in terms of the general feel. Okay, now, where's the fun stuff? Is that coming yet, or do I have to end the video already? I might be rusty. I'll get better. Don't worry about that. Because I'm bad. Or maybe I'm just, rusty. Yeah, rusty is just a nicer way of bad. Right, translating. So if you have some vector, you translate it, you poof it up in the same direction. Its direction and magnitude, that's all vectors are. In the sense of Cartesian coordinates and, without going into linear algebra. Right, like, I said, like, some of the variables are arbitrary. 3 dimensions, like x, y, z, they're the unit vectors, which are just vectors of length 1, are called I hat, j hat, and k hat, and they form the standard basis. And the definitions of these use the, like, x1, x2, x3 notation, so if you're taking the class, I recommend you do get used to them, or you'll get owned.